Lesson 9.4 is all about variation. We have direct variation, joint variation, and inverse variation. And we're going to look at how each three of those look and some examples of each. So the first one we're going to look at is direct variation. And this occurs when we have mainly two variables and our k, or our constant of variation, being applied in the case that it looks like y equals k times x. Now an example of how this would work would be if we have a circle and it has a given radius then, well that circumference would vary directly with the length of the radius. And by that I mean if we get a bigger radius then, we would have also a bigger circumference. If the radius were to get smaller, the circumference would get smaller. So in that case, we would say circumference, c, equals k times r. More specifically, circumference equals 2 pi times r. So this 2 pi would be our k value. Another way to look at this as like a real life example would be your paycheck. If you work for an hourly wage, you would say then that your pay equals, let's say you got $8 an hour, so 8 times however many hours you work. So if you want more pay, you want a higher pay, you have to work higher hours, you have to work more. If you decide, oh, I'm not going to work as many hours this week, so I'm going to work for less hours, then you're going to get less pay. So they vary directly. If you, let's say you got $56 this week, and it was $8 an hour, then you know that you worked exactly 7 hours. So that's direct variation. Another type is joint variation. And joint variation occurs when we have three variables. We would say then that y equals that constant, k, times x times z. So one way to look at this would be like area. So if we have a rectangle, length, width, and area, we would say A for area equals our constant. In this case is just going to be 1. Actually, maybe I'll use black, just a black 1. 1 times length times width. So no matter what, your length times your width times 1 gives you your area. So if you want a bigger area and you're going to keep your width the same, that means you're going to need to increase your length. You're going to have to get a longer rectangle to get more area. If you, let's say, keep the length the same and you decrease the width, that means your area is going to decrease as well. And so again, those look like y equals k times x times z. And the last one is called inverse variation. And a good way to look at this is to think about traveling a distance in a car. So if you have your set distance, say from Byron to Minneapolis, that rate varies inversely to time. So if you go slower, it'll take more time. If you go faster, it'll take less time. So we would say, we could write this as x times y equals k, or we could look at it as y equals k divided by x. So to solve these variation problems, we would write out the general equation for whatever one we're looking at. So again, we need to know, are we looking at direct, joint, or inverse variation? Write out the equation with the variables in k, substitute in our given knowledge, and that would help us solve for k. Write out the particular equation, so we just have our x, y's, and maybe our z's, and we plug in the value of k that we know into that equation, and then substitute the rest to find our answer. So let's see how this one looks. If we have direct variation, so that's y equals k times x. So in this case, we know that y equals negative 15 when x equals 5. So negative 15 equals k times 5, which means then, if we divide both sides by 5, negative 3 equals k. So we would say then y equals negative 3, that's our k value, times x. And we would plug in x equals 3 right here. Y equals negative 3 times 3, so y equals negative 9. Try that one more time. We have another direct variation, so y equals kx. And we know y equals 12 when x is negative 3. So 12 equals k times negative 3. Divide both sides by negative 3 then, that means negative 4 equals k. So we would say y equals negative 4x, and we know that x is 7 in this case. Plug in our 7. Y equals negative 4 times 7 is negative 28. So that would be solving for direct variation. Now let's try joint variation. So again, we have 3 different values that we need to be looking at here. So we would say y equals kx, whoops, that's a z, kxz. And what we know, if y equals 12 when x is 3 and z is 8, 12 equals k times x is 3, z is 8. 3 times 8 is 24, so 12 equals 24 times k, which tells us then that k equals 1/2. 1/2 of 24 is 12. So we would rewrite it as y equals 1/2, that's our k value, times x times z, and we know x is 10, z is 5, 10 times 5 is 50, and 1/2 of 50 means that y is 25 in this case. So that's a joint variation example. Another joint variation example, so again, y equals k x z. If y equals 11 when x equals 5 and z is 22, so 11 equals k, x is 5, z is 22. 5 times 22 comes out to 110. So divide both sides by 110 to find that k equals 1/10. So we know that y equals 1/10 of x and z. In this case, say x is 3 and say z is 2. 3 times 2 is 6. 1/10 of 6 means that y equals 6/10, or reducing down, we would say y equals 3/5. So that was another joint variation example. Now we'll try inverse variation. So I prefer to write these ones as y, or we'll call it a. A varies inversely as b, so we'd say a equals k over b. So that's the form we're looking for. We know a is negative 6 when b is 2, so negative 6 equals k over 2. So we want to find a when b is negative 7. Well, first we have to solve for k. If negative 6 equals k divided by 2, that means negative 12 equals k. So a equals negative 12 divided by b. b is negative 7. Negative 12 over negative 7 means, in this case, a is positive 12/7, because negative over negative, the negatives cancel out. And another one of inverse variation. So again, if we have a varies inversely as b, that means a equals k over b. A is kind of like our y and b is kind of like our x. And we know that a is 2 when b is 8. And we need to find a when b is 6. Well, we still have to find what k equals. So multiply both sides by 8, k equals 16. So we'd say a equals 16 over b, and we know that b is 6. 16 divided by 6 then, a equals 16 over 6, or, simplifying it down, taking 2 out of each of these, 8 over 3. A equals 8/3. That would be yet another example of inverse variation.